Okay, I am going to do number 26 here, and I'm going to do it on the TI to give you an alternative method for doing this. So we have one study of smokers who had tried to quit smoking with the nicotine patch therapy. 39 were still smoking 1 year after treatment, and 32 were not smoking 1 year. Based on this data from this journal, use a 0.05 significance level to test the claim that among smokers who tried to quit with the nicotine patch, the majority were smoking 1 year after the treatment. Does the results suggest that the nicotine patch is not effective? Okay, so we want to start by writing our null and alternative hypothesis. So our null is going to be that P is 0.5, 50-50, no change, nothing matters. Either one's the same as the other. Alternative, we want to prove that more than 50% are still smoking, okay? Because that's what this says, that the majority, so majority means more than 50%. So this is our setup here. And from this, we know that then 39 were still smoking a year after, and our N is the two together, 39 plus 32, so 71. Okay, so those are our information. We want to test at 0.05 significance level. Now on the TI here, you are going to bring up stat, and you're going to go over to tests, and you are going to go down to this 1 proportion z test, so number 5, okay? This here is 0.5, okay? Ugh, I don't know what I just hit. Okay, come back. 1 proportion. Okay, so this is 0.5. So this is what we're testing, our null. This is this value right here. This here is our x, so 39. 71. As a note, you can actually shortcut this, and if you put in 39 plus 32, it will work it out for you, which is kind of nice. See, it did it for you. Now we want that our value is larger. We want this one, okay? Because we're trying to eat our value here, so this is going away from our p sub 0. So you can see here p sub 0, which is 0.5, is on this side. So that's just kind of the way you read it. And then I'm going to come down here to calculate. Don't double press enter because it will disappear. So there's our null, and you can see right there that matches our alternative. Here is our z-score. So this is our test statistic, 0.83. This is our p-value, 0.2. So with p-values, you compare your p-value to 0.05. If your p-value is less than this value, you will reject. We are so not. So we would fail to reject the null. Now, many questions will still ask you for the critical value. So to find the critical value, and you've done this a bunch of times, you go distribution, you go to inverse norm, okay? And we want 0.05, but this is one-tailed, okay? That means it's all in one. So I actually put the full 0.05 here. I don't divvy it up. And so 1.645 here, this is my CV. So if I needed that to be able to test something, I would use that. Now, that then helps us with our picture here. So we are only here on the upper end, 1.645, and we want to know if our value is out here. And you can see that what we got, the value is 0.83. 0.83 is somewhere back here, right? And that's why it's not in the rejection zone. So when you're looking at this to decide if you reject or fail to reject, you're looking, does your value surpass that? Does it end up in one of the tails? And that's the same thing you're doing, because the idea is this is 0.05. Your p-value, the 0.2, I keep going back and it's not there, is bigger than that. It comes, all the way out to here. It's 0.2. Well, it could easily not be in there. So therefore, it's not. It's too big. To do that, it would have to be smaller than this 0.05, which is the only area we have left. So we would say we fail to reject the null at 95% confidence, okay, or significance, whatever you want to use. And then you would also then go on to say, we are unable to prove that nicotine patches affect quitting smoking. Now, when you fail to reject, you never get to say anything cool. I don't have sufficient evidence to prove it. I can't prove that more people are still smoking a year after. Now, looking at this, hey, the sample proportion was higher. Oh, excuse me. But statistically, I can't prove it. It's not high enough in comparison to my sample size to prove it. So I'm unable to prove anything cool. When you fail to reject, it's kind of okay, try something else, look at something, you need more data. It's telling you, go back and try again.